Our task for today is to find and count duplicate elements, very common theme, both in programming interviews or coding interviews, as well as in the real world, since a lot of times we want to either figure out if there are duplicates, maybe we're interested in the duplicates themselves, or sometimes we want to deduplicate, we want to remove them, we want to ensure uniqueness. And in this case, we will do both finding and counting, but no deduplication. And first, we'll start with counting. Here is some additional description. Given an integer vector, count how many duplicates exist and list the elements that are duplicated. And one example, we have following vector, 5, 10, 15, 5, and 3 two times. Yeah? And of course, we have two elements that are duplicated, so the count is 2. Elements 5 and 3 appear more than once. And if we want to list those elements, the second task or the second part of this task, we return a vector with those elements inside. So let's start with the counting, and we will do 3 approaches. As usual, we try to compare various ways in which you can solve it, also the ways which are not really optimal, or you shouldn't do them, but still people do it just for the sake of discussion and for the sake of comparison. And that's usually where we start, and that's also what we will do today. So we'll start with n squared, O(n squared) time complexity, and then we will see how we can improve that dramatically or drastically using some more appropriate data structures, mainly data structures which are hash-based, like sets and maps. And then for by the very end, we'll also use we'll try to find the duplicates themselves, so not only counting, and we will only do it for the optimal with the optimal approach. And then we have some tests which are already prepared for us, so a lot of helper functions which are just used to call the tests themselves, and the actual test cases are here. We have a test case with no duplicates, with 2 pairs, with overlapping duplicates, with all elements being the same, like 8, 8, 8, and so on, and just with single element. And then we will call them for all our counting functions, and then for the finding function. Okay, so let's get to the top. Let's get back to where we started, and let's start implementing the unoptimal way. We can create a vector, which is not a bad approach, but better would be to use set and store the values that we have seen so far, or the duplicates that we have seen so far. And in addition to that, we can have some counter, which will start with 0, and then each time we find a duplicate, we'll increase it by 1 or increment by 1, and by the end we'll return the counter. And now, of course, we have to go through each element for not count, but for const auto number in our input array. We will check if it appears more than once. If it appears more than once, so if count, and we use iterators for count. Count comes from algorithm, and we can count how many times given element appears in the array, but we don't provide like the array itself, but the iterator starting from start till the end, because we can theoretically do it on any subset of given array. And or if we have 2 of them stored continuously in the memory, then we can do it also on more than one array. But let's start here. Array begin, array end, and we want to count occurrences of our number. And if it's more than once, that means that we have found a duplicate. But how to prevent recounting the same duplicate more than once? Well, we can use seen, and if we have seen it already, then we will not count it more than once. Yeah, so here we put exclamation mark, and now we can add it to the scene pushback to the scene vector. We add our number, and we have seen it, or we have encountered it first time, and we increment the count. Now we can close our if block. That's it. Now let's try to compile. Duplicates, and let's compile it to exam. And all the cases for duplicates simple pass, but of course it's not efficient since we call this count function for the whole input array on each number. Yeah, so we do an on operation inside an on loop, ending having n squared complexity. So in the end we have n squared complexity, which is usually not what we want. Well, the better approach is to use sets. We can use unordered set. And again, we will store scene elements, but we will store also unordered set. We will still store also duplicates. So the ones that we have seen so far go into scene, and the ones which are duplicated. So the first time we encounter, maybe this the better explanation, we'll put them into scene, and the second time we encounter, we put them into duplicates. So now again we do the same loop. We still have to go through each element at least once. And here, if we have seen the element already, then we insert it to the duplicates. Otherwise, else it means that we seen it first time, and we can add it to scene. Insert. Then let's return the size of the duplicates. And what will happen if we have a given duplicate duplicated more than 2 times? Well, the set will handle it since it stores already each element once. So if we insert here 2 or 3 or 10 times the same element, doesn't matter, it will still in the end be stored as a single element in our set. So now we can try to recompile, and all the cases pass. Now the final and maybe the most versatile or the most common approach is to use an unordered map. From int to int, and we can call it frequency, for example, or histo or something like this. And first, we can also do some counter, and then we can go through each element. And for const auto number in our array, we add it to as a key to our frequency map. So by default, it will be mapped like the value will be mapped to that key will be 0, and then each time we encounter it, we increase by 1. including the very first time. But the default one will be 0. And then we can iterate again. And since the loops are not nested, we are still in O(n) time complexity. Key and value through our frequency. And if value is greater than 1, that means that we have a duplicate. And we can increase the counter. And by the end, we return the counter. And everything goes smoothly so far. And now the last case, we want to have the numbers themselves. And let's copy from here. So let's do copy it here and copy back here as well. And it's almost the same, except that we don't want any counter. We want to have the numbers themselves. So we will create a vector. And that's also the signature of our function. So we want to return a vector with duplicates. And here we'll simply push back each duplicated, not value, but key. And the value are the frequencies. And here we can return the duplicates. So let's compile. No warnings, and all tests passed successfully.